Hello Sparkers, this is Instant Kafka. Welcome to part 3 of the series on maze generation. Last time we had gotten our generator to generate the grid we're going to use for the maze and to tell each cell to find its neighbors to the north, east, south, and west. Now we get down to the real business of generating a maze. First thing I need to do is clean up a little bit. Let's move this initialization stuff over to its own page. Just make things a little tidier here. Paste this in, move all these, boom, 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 and delete that. Alright, now on here we can just say call initialize. Don't know which one of these has a space at the end. Values, text, new text, initialize. Okay, get rid of these. Find my neighbors. If find my neighbors is flagged, call that page. Call debug. Initialize is good. Find my neighbors is good for now. Alright. Let me consult my little cheat sheet here. There's a lot of code here that we're going to have to get to. Bear with me. I have all my, just to let you know, I worked this out before, and I have all my new code on these little code share cheat sheets. That's what I'm doing. I'm not good enough to memorize all this stuff. So, maze generator main. We're calling our initialize. We're doing all this rigmarole with the current stage. Let's get rid of this and just call it directly. This stuff works, but kind of just distracts from the purpose of this. Stage 1. Okay. Frame count's fine. Once we call stage 1, we need to make sure all the cells are initialized. So we look through and wait for all of these to report that they're initialized. Then we go on to stage 2. Get rid of those. Initialize looks good. Stage 1, just creating a grid. Stage 2 is saying, hey, find all your neighbors. Okay, this is one thing that really kind of bugs me. The way this is doing it now is it's looping through all the cells and telling each cell to go find its neighbors. I would rather the neighbors figure that out for themselves. And the way we can do that, I'm sorry, not the neighbors, the cells themselves, to figure out that they need to look for their neighbors, is we'll just set this as a global. Global neighbors equals, or global find neighbors equals true. Once we do that, oh boy, I lost my stuff here. In here, instead of calling find neighbors, this is a local variable. Let's say global find neighbors. We also don't want to call this more than once. If we've already called it, if we found out that find neighbors is global find neighbors is true and we call find neighbors and we're done, we don't want to call this again. So in our find my neighbors here at the end, once we're done, we set this neighbors found to true. So here we'll just say and neighbors found, actually and not neighbors found. So if the global flag was set and we haven't already found our neighbors, go ahead and find it. Okay. That should work. back to the maze generator code. Okay, then here we just loop through and wait for all the cells to report that they found their neighbors. And we move on to stage 3. Alright, stage 3 is where things really start to happen. The way this is going to work, it's called the growing tree algorithm. There's a bunch of different algorithms for generating mazes. This is just one of them. It's one of the simpler ones to do, so and it gives good results for what I'm looking for, so that's the one I'm going to use. The way this works is we start by randomly picking a cell in this grid, any cell. So let's say we pick this one right here. We pick this and we store it in a separate object set. Call it tree or branches or something like that. That's our tree. This tree is going to grow as we go along here. But right now the only thing in this tree is this one cell. After we have something in our tree, we go in and randomly select one of the cells in our tree. And after the first one, there's only going to be one in there, so that's the one that's going to be selected. And we're going to tell that cell, go out and randomly pick one of your neighbors. So it'll go in and pick either the north, the east, the south, or the west. Randomly picks one of those, and that one gets added to the tree as well. So now the tree contains both of these nodes. These nodes are no longer considered for random selection later on. So we're going to have to set some kind of flag in there saying that these have already been processed or visited or something like that. So we got those, and we just continue on. The next time around, it randomly selects one of these two. Say it selects this one again. Then it has this node, and this node, or this cell, and this cell to pick from. So it randomly picks one of those. Let's say it picks the north cell. Now these three are in the tree. And it goes through again and says, hey, pick a random cell from the tree, one of these, and let's say it picks this one this time. And then it just kind of grows out like that, and it looks kind of organic as it's growing out. All these different branches coming off. Once a cell in the tree can no longer randomly pick one of its neighbors because they've already been visited, it removes itself from the tree. It's no longer considered when it tries to randomly pick one from the tree. And eventually all of these cells will end up in that situation, and our tree will have no cells left. And at that point, the maze is done. It's generated. It's really hard to explain. It's better to show you, but that's how that's going to work. So for stage 3, we're going to move this stuff over to stage 4. So let's copy this first. Copy this page. Paste this page. Get rid of that. So we have stage 3, and then we have stage 4. In stage 3, we are going to first randomly select a cell, and the way to do that is to randomly select one of the indices of the cell, of the cell. So randomly select a number between 1 and the number of cells we have. So this is going to happen on page enter. So random index equals random. Okay. 1, 2, cells count. Oops. Count as integer. Alright, now we have a random index. Now we loop through our cells until the current index equals our random index. And that's the item we're going to take. This is the only way I know of currently way in Project Spark to access items by their index, by the way. Somebody knows a better way, please tell me, because this is kind of inefficient. Current index. When current index equals random index, we're going to set our target. Then we're going to add it to our tree. New object set, we'll call it branches. I would use tree, but branches, it's easier to tell that there's going to be more than one of those. Increment by target. Add it to the branches list. Then we need to indicate that this target, this cell, has been visited, so we don't consider it again for random selection of the neighbors. Target is visited. Do we have that yet? No, we're going to create that. Let's create that. Let's make sure we specifically create that here in our initialize. Boolean is visited. And initially is false. Target is visited. Oh my gosh. Is visited equals true. And kind of the same way that we tell the cells to look for its neighbors, we're also going to tell the one cell that we picked to find or randomly pick one of its neighbors. So we're going to use another global for that. Global. Current branch. Equals a target. Alright. Now in here, we're going to have to say something about, we're going to have to look for that somehow. So we'll say when global current branch is me, this cell is the current branch. We're going to go ahead and call page. We don't have the page yet, but right here, let's create a new page for picking a random neighbor. Pick random neighbor. Current branch equals me. Call page. So when the current branch is this cell, it's going to call the code to pick a random neighbor. Let's go back to here. Oh, stage 3. We set the global current branch equals target there. Okay. So what's next? Checking my cheat sheet here. On the pick random neighbor page, this one's kind of important. And it's kind of repetitive. We're going to say, well, let's go back for a second. Let's back up for a second. when we find our neighbors, all we're really doing here was just trying to indicate that we found a neighbor. We have a neighbor count, we just incremented by 1, but what we really need to do, we also set, you know, the actual neighbors, but what we really need to do is keep a list of our neighbors. The other thing we need to do is keep a list of potential neighbors that we could actually randomly pick from. And these lists initially will be the same. They'll be all the neighbors that it has of the cell, but we always want to keep our neighbors kind of static. We want to just be able to loop through those and treat those as a set together. But the neighbors that we could pick from for randomly picking the next neighbor, that can change. So let's do that here. Let's create 2 different object sets. We're going to have our neighbors object, which is set initially and doesn't really change. So that to the north cell. Here, set this to the east cell. This one, set this to the south cell. A lot of repetitive code, I know, but bear with me. West cell. And then we're just going to do the same thing for another set, object set. We'll call this one potential targets, because these are going to be ones that we can pick from, randomly pick a neighbor from. Once it's picked, though, we can't pick it again, so we're going to remove it from the list once it's picked. Okay, so this is a object set, potential targets. Okay, just copy this. Potential targets. Copy. Just paste it in here on this. Potential targets. Like I said, these start off the same, but we're going to change this one around as we go along. So in our pick random neighbors, the first thing we're going to do, we're going to have a target. This is going to be called multiple times. It can be called multiple times. So we want to initialize our target first to nothing. Otherwise we can end up with this as a value from the last time this was called. So initialize this to not north, nothing. Then we're going to loop through our potential targets and check that is visited flag. If this particular tile, or I'm sorry, this particular cell has been visited before, then we're going to remove it from our potential targets. We can't consider that as for randomly picking it. Potential targets. When it is visited, remove it. Okay, now we have a nice trimmed potential targets of only those neighboring cells that we can actually pick from. The next thing we need to do is check if we have any left. We might not have any more potential targets left. So we'll just check the count. If it's greater than 0, then we got something to work with. Then we just randomly pick one. One of the potential targets that's left. Do the same thing with the random index. Random index equals random number from 1 to potential targets dot count oops, dot count. Until I'm a programmer. Dot count as an integer. Okay. I think of all these things in object-oriented terms, so all these things are dot properties. Alright, so we get our random index, and then while we're still under here, this condition here, we're going to loop through our potential targets and find the one that we just, find the one with the index we just randomly picked. When the current index equals our random index, our target equals it. Okay, this all happens if we still have potential targets left. If we don't have any potential targets left, this is a dead end. We need to remove it from the list, from our tree, so it doesn't get called anymore, it doesn't get randomly selected. So we'll say else here. Our creator, that's the one that's maintaining the tree branches. Remove me from the tree. Okay. There we go. So we've trimmed our potential targets to only the ones that haven't been visited yet. We randomly selected one if one exists. If not, we remove ourselves from the tree. Okay. Now at this point, our target will either be one that was randomly selected, a randomly selected neighbor, or it'll be nothing, because we set nothing up here. If it doesn't hit this code in here, it's going to be nothing. So let's check that. When target we have a valid target now. Now we have to consider this one visited. It can't be used again. It can't be randomly selected again. Equals true. Okay. Now the fun part. We need to maintain our, we need to have each cell remember which cells it's been connected to. When it randomly selects a neighbor like this, it's saying I'm going to connect to that neighbor. So the way I implemented it was, the way I figured this out was to just check to see which neighbor it was, if it was the north, the east, the south, or the west, and we'll set another flag for each direction. So if the target equals north cell, go ahead and set a boolean, call north connection. It's true. Now, when we pick our random neighbor, we know that, like, if it was the north neighbor that we selected, we know that it's the north connection we're connecting to, but our north neighbor's south connection is also connected to us. So we'll do that. North cell's south connection equals true. Okay? And we can just copy and paste this for the other directions. We have east. We have an east connection. And then our east cell's west connection is also set. Boolean east, south connection, and our south cell's north connection. Oh, it's a little weird here, but north connection equals true. The last one is west. West is always last. It doesn't have to be. It's just the way I've been doing it. West cell's east connection equals true. All right. So now we've determined, once we picked our random number, we've connected to that, or neighbor, not that number. We've connected to that neighbor, and the neighbor is now connected to us, to this current cell. All right. Now we're done. We need to indicate that we're done. So we set that global current branch to nothing. Oops. Nothing. All right, we're done. Well, we're not done, but all right. Back to here, stage 3. Global current branch equals target. Once that's set, that code we just entered is going to run. It's going to randomly select a neighbor and set the connection to it. It could also have removed itself from this branches set because it didn't have any neighbors to select. So that's what we need to check here. We need to check if we still have anything in our branches, in our tree, left to check. If we don't, we're done. The maze is generated. Switch pages to stage 4. Otherwise, we still have branches. Now we make sure that it's done. The current branch is done doing whatever it was doing. So we have to check for this global current branch. Now we're ready to select the next one. Remember, this stuff up here, this is called when the page enters, just to select the initial one. And this is selecting from our overall grid, the cells. Now we're going to select from our tree, from our branches here. But it's pretty much the same thing. As a matter of fact, we just copy this here. Copy. Yeah, I do need that. Okay. Not global, then in here, paste this, get rid of that, indent this. Random, okay. Random index equals number 1, 2 branches dot count, or branches count. Here we're going to look through our branches. Current index equals random index, target equals it. And we're done executing here. Don't need to keep looping through. Executing. All right. That's pretty much it. If all goes well, how do we tell if it's done? Okay. Alright, so now we just need to check this. Stage 2, stage 3. Okay. Let's double check our main page of the cell. Initialize first. Cell width, cell height, cell is visited, is initialized, that looks good. Global find neighbors and not neighbors found. Call page find my neighbors, okay. Current branch equals to me, then we call pick random neighbor. Otherwise we just call debug, okay. Find my neighbors. Do an raycast to the north, setting our neighbors, and we're setting our potential targets. Neighbors, potential targets, neighbors, potential targets, neighbors, potential targets. Neighbors found equals true. Find neighbors equals false. It should be global find neighbors, right? No, we don't set that. We don't even need this. If we set this to global, if we set the global find neighbors to false, so anything that hasn't run yet, any other cell that hasn't run yet, won't ever run. Okay. Pick random. Excuse me. Target equals nothing. That's our initialization. We loop through the targets and say it is visited. If it's visited, remove it. Potential targets equals 0, then it's greater than 0, sorry. Get the random number, go through and check it, target equals it. Okay. Still doesn't look like it's working here. Else, then we got the target is visited equals true. Okay, just checking if I have these lined up correctly. When we have a target, target is visited equals true. Oh. These have to be part of. That condition. Let me do this if we have a target. Okay, we set our... Then at the end here, oh, we need to add this to the branches, that's why. We need to add our targets to the branches after that. To the tree. Doesn't have anything else to work with if we don't do that. Okay, this runs regardless. This all runs only if we have a target, but this one runs at the end, and we're done. Now, after about 4 seconds, it should pop up and say something here. And it's still not. Okay. page is entered, we get the initial random cell. Okay. Add it to the branches, add it to our tree, set that it's been visited, set our global current branch. Okay. Once that's done, oh boy, this also has to be in here. That's what I get for doing the code share. I gotta mess up my my indentation. And the target, do all this. Okay. Now, branches count equals 0. Switch page to stage 4. If we don't have a global current branch, go ahead and randomly select one from our tree. No, not target. We set our current branch, because that's what we're checking here, equals it. Then we're done executing. Now let's see if we get... There we go. The initializing 5 frames is obviously a lie. We'll fix that. But it's actually generating the maze, and you're thinking, oh, well, that's not too exciting. I don't see a maze. Well, we haven't really shown anything. We haven't done anything to show the maze yet, but trust me, it's there. Let's fix that right now. If we go to the debug page on here, actually, let's go here first. When we did all this, we checked the north cell, and then we set these north connections and south connections and east connections. We can use those in the debug here. You're going to do that by drawing lines from this cell, from the center of this cell to the center of whatever cell we're connected to. Okay? And in order to do that, we're going to take the center of this cell and we're going to offset it up a little bit so we can see, so it'll draw the line just above the logic cube. So let's define our offset first. Offset from the center of this cube. This is going to be a vector variable. And we want it up. And we'll say let's say half the cell height, or a little more than half the cell height, because we're starting from the center. It's a cube, so it'll be about a little more than half, let's say, cell height. Oh, we multiplied. Cell height. Multiplied by, and a little bit more than half, 0.5. Let's go 0.51. Okay, that's just so it'll show up just above the cube. All right, now the other thing we can do is we can indicate when this cell has been visited. If it's changed, it's gone from false to true. So we can set that. That makes sure it only happens once. Sorry, I'm losing my stuff here. Okay. Set the solid color to yellow. It's kind of purplish right now. We'll set it to yellow. Then we check each connection. North connection. When we have a north connection, let's draw a line. from this cell center plus our offset to the north cell center plus the offset. And we have a yellow, we're going to have a yellow cube when this is done. So let's do something contrasty like black. Okay, it's kind of an awful long line, but all it's doing is drawing from the top, center top of this cell to the center top of its north neighbor. Do this for east. And south. Oops, that one. And west. Wait, 1, 2, 3, 4. West. Nothing else changes, right? Alright, now if we do this, now we can actually see the tree grow. Zoom in a little bit more here. There we have it. Perfect maze every time. Let's see if we can center this a little better. There we go. Okay, this one's run a little long, and it's very, well, not very complicated, but it's more complicated than normal, so I'm going to stop it here. On the next installment of this series, we'll talk about how we can actually use this rather than just draw these lines from the center of each cell. We'll talk about how we can use this for maybe some terrain modification, or maybe start generating walls around this, or whatever. So that's what the next one's going to be about. Thanks for watching.